Hello and welcome to the Devtoberfest session, Develop Metadata-driven Apps with SAP UI5. My name is Benedikt Schoelch and I'm a product owner in the MDC team, and I'm going to lead you through this session today together with my colleague Thomas Buechler. What is SAP UI.mdc? SAP UI.mdc is a library for efficient application development and the foundation for metadata-driven controls. It's usable with any UI5 model or data protocol, and it's not dependent on a specific model or protocol itself. This is a differentiator from the well-known Smart Control library for OData v2, which was tightly coupled to OData v2 and annotations. The MDC library is foundation for the SAP Fiori elements for OData v4, who have provided an equivalent to the smart controls for v2 with a flexible programming model, aka macros. A little disclaimer at this point. The MDC library is currently only experimentally available, but we will want to make it generally available with UI5 too. So until then, please try it out. We would appreciate your feedback. At this point, I would like to mention some of the key features of the MDC library. It consists of smart composite controls, which are smart because the SAP, the well-known SAP Fiori UX design is incorporated in these metadata-driven components. This means you don't have to take care about theming, accessibility, and all those things because they will come out of the box. With the MDCs, we also decoupled generic like UX pattern related behavior from application or protocol specific requirements. So that means you can use the control under any circumstances. And last but not least, all the usual powerful UI5 development concepts like data binding, internationalization, and all of those are also supported out of the box. It's extensible via API. That means we have provided so-called delegate APIs for you to extend the controls and implement the behaviors you would like them to have. So they support a well-defined API for supplying metadata in a unified and protocol agnostic format. This is the way how you provide metadata to the MDC control. And they can leverage XML preprocessing to improve the application startup performance. It doesn't mean they have to, but you can make use of it if you want. For personalization purposes, we decided to integrate the SAP UI5 library, SAP UI5 flexibility, out of the box for you. So that means personalization works, key user variants and user variants work, and you don't have to take care of the integration aspects. You might even get some performance advantages as the flex changes which are created when you personalize controls are used to fill the application cache, and hence you benefit again from application caching. To give you a brief and simplified architectural overview, because we don't have much more time in this session to do the deep dive, I want to show you this diagram. It shows the MDC control, which implements, as mentioned, the UX design and creates this UI based on the metadata you provide. And on the other hand, there's the delegate, the gray part. This is what you will have to provide, which is the interpretation of the service metadata encapsulated. And it provides this metadata in form of property info to the control, as you can see. Control requests via fetch properties, and the delegate reads the service metadata, translates it into property info, and returns it back to the control, where the control will take the metadata and will create items based on the property info. So specific item creation is also implemented in the delegate. This means you can choose for which kind of metadata, which control should be later on be displayed on the UI. Today, we would like to have a look at certain controls specifically. So first of all, we want to give you insights into how to use a table and show data in tabular formats with columns and rows based on the metadata. We want to show you how you can filter this table with a filter bar and create complex filter conditions. And we will also integrate value helps in this filter bar that that are specific that can deliver specific assistance for the user when inputting data. We will show you how you can integrate and make custom types known to the MDC runtime via the type map utility, and we will show you how we can use those custom types in your metadata and in the XML view. And last but not least, we're going to show you how variant management and personalization is supported in the MDC controls and how you can store these personalization settings. I hope this made you curious and you're now eager to develop your first application with SAP UI.mdc. In this session, we're going to have a guided tutorial. That means there is a link below which leads you to the tutorial that you can do live with us, or you can just look at us, how we code through, and then later on do the tutorial on your own to apply the newly learned knowledge you got. And with this, I would like to hand over to Thomas, who's going to guide you through the first exercise. Have fun.
Hello everyone, my name is Thomas. I'm a development architect working in SAP UI.mdc, and I'm happy to present you this newly released library. Okay, let's start with exercise 0. Before we can start coding our application, we have to set up our development environment. In our case, we want to use Business Application Studio. And to start here, we just need to import the provided zip file from the tutorial setup steps README file, which will then lead to this nice application structure to our left here. And when you open a terminal, and then install all the necessary node dependencies for this project. After doing so, you can already serve it. This will lead to some additional dependencies being installed. When you open the provided link, you should see the application up and running. So exercise 0 is already complete. We can move over to exercise 1. So as our application is not very useful right now, we actually start by adding some data we want to visualize. For this, we will make use of the MDC table, and we will start by implementing an table delegate for it. This delegate is based on the same principles as with all the other MDC controls. All the model and application-specific coding should reside here, so you don't have to modify or extend any modules. So we will start by creating this JSON table delegate, and we will add some of the boilerplate we have already prepared here. Okay, this little bit as well. And you can already see we leverage a base delegate, which is provided by MDC, and we'll enhance it a little bit. Okay, the first thing every larger MDC control will need is some property information, and in our case, this is stored in this separate file here. It's basically a structure describing the data we want to display with our table. You can see here our mountains have lots of properties, like a name, which is a string and should for sure be visible, and also a height, which is integer based, is of interest, and lots more properties are available. So we will now enhance our delegate by providing this information to the control. And we will return the property info mentioned before, which is already available as a dependency up here. So the next thing is some basic configuration which tells the table which data to bind to. As applications can decide for themselves how to transport that information, there is no default to do this. So in this case, we will try to transport it via our payload. Like so. Okay, to actually see something in our application, we also need to enhance our XML data. So we grab our view and we will just copy lots of code into it here in our content section. So this is mainly our control definition here. You can see it's an MDC table with some personalization being enabled, and also the delegate we just created before is configured on this table instance, and we also provide some payload, which is basically the binding path we need in this update binding info method. So if we did everything correct, this should already be enough to see something, and we already do. So that's very nice. Additionally, we can now enhance our delegate a little bit further. So to actually make use of the personalization we have enabled on this table instance, we have to implement methods like add and remove item. Every larger MDC control is an aggregation-based control, which is able to add or remove internals which the user can work with. So, for example, a filter bar may add or remove filter items, and a table may add or remove columns. And yeah, I think you can guess the principle. So, yeah, we tell basically this table how to create its columns by providing this add item method, which will make use of this add column method we have in here, which basically just states, okay, create a new column, put a sub m text into it, and bind it to a given path, depending on our property info, and also make use of the provided data type in that property info. So, and just for the sake of completeness, we will also add a remove item functionality to our delegate as well. And that should be it for now. So when we reload this application, we should already be able to add and remove columns. That's it for this exercise. Let's move over to the next one.
Let's continue with exercise 2. In this exercise, we will create a filter bar delegate and add a filter bar to the XML view. We're using the filter association of the table and implement a search functionality as a combination of filters. First things first, let's start with creating a new delegate. We call it JSON filter bar delegate.js, and we can have the following boilerplate here, which contains the already well-known fetch properties call. That's gonna fetch the property informations from the JSON property info file, which is kind of a simulation of an actual service metadata. So usually, yeah, your service would probably deliver some metadata along with the data that you can use to translate it into JSON property info file, which the MDC framework can understand, and return it here to get the right representation of filter fields for your filter bar. Next step is to add the filter bar to the XML view as well. So we're gonna place it in the dynamic page header. And as you can see, we have two fields of this filter bar already defined for the initial view. That's the basic search field and a filter field for the property name. Another thing which we have to do is add the filter association to the table and refer to the filter bar. As you can see, we have the ID filter bar for our filter bar, and we can just use it here in the table. Refresh it here, and as you can see, we already have a filter bar that looks pretty good. We have a name field which we can filter for, and we could, for example, say, let's find all the values that start with Mount, and this works already. So we find the Mount Everest. Let's try the same thing with the search field. Okay, does nothing, as expected, because search functionality is not yet implemented. How can we do that? For that, we have to go to the table delegate, because the table is actually the one who is going to apply all those filters which we provide. The default implementation already handles a lot, but if we want to do a custom search functionality like we do, which is, let's say, a more specific filter field in our case, we have to implement that on our own. Therefore, we can override the actual table delegates getFilters call and create our own search filters based on the properties name, range, parent mountains, and country, and concatenate them to the filters array and return it by getFilters through getFilters. So by doing that and creating just standard model filters, which we return here, we can make this search field work, and it will find not only the Mount Everest, but also all of the mountains that have the parent mountain, Mount Everest. And that's pretty much it. Easy as that. Another thing we would like to do is making our filter bar adaptable. Currently, that does not yet work. As you might remember from the table delegate, there are some callbacks which we need to implement for that. Those are the following. We have the add item functionality and the remove item functionality, where the add item functionality is responsible for creating a filter field instance based on the property info which we've passed and gets all of the according settings here. And the remove item is responsible for destruction of the according filter field. And if we now refresh our application, we can see all the filter fields are available here, and we can configure ourselves a very nice view. Easy as that. This was exercise 2. We're already done at this point. And if your application looks at the moment like this, you're good to go to exercise 3. Let's build some advanced value helps in exercise 3 and integrate them into the filter field. This enhancement will improve the user's filtering experience and expedite the search for desired results. Let's start with the definition of our value helps. We create a new folder called fragment because we make use of the nice modularization features the UI5 framework provides to us. And we create a new fragment called range value help, where the range is the property which we are going to build the value help for. And this looks as follows. In this XML, you see the crucial parts of the value help. We have the value help instance itself, which has the aggregation type ahead, which means here a table will appear below the field as a suggestion list, where we have a popover and a so-called mtable wrapper. This connects the table that is used inside to our field and the value help instance, so it serves as a wrapper. And inside the table definition you can see here is just done like in any other UI5 control. So we define the binding up here against the ranges and bind our table cells against the range property. right away, we also add another value help at this point, which we call name value help. This one is a bit more sophisticated and contains some more functionality. Let's start up here. It's pretty much a similar setup than before. We have a popover with the mtable wrapper. But additionally, we now define a dialog for this value help. So on top of the suggestion list you get, you also will have the possibility to open a dialog. The dialog comes with an MDC table wrapper this time, which encapsulates not only an MDC table, but also a filter bar. Inside of this value help, we really have a little MDC application itself. Yeah? We're reusing the delegates we've built before. It might happen that in a productive environment, you might want to refer to a completely different entity set here that just relates to the data you show in your original main table. But as we just have a little bit of data for this demo available, we're just using the same to show you how you can actually set it up. As said, inside there is a specific value help filter bar that also contains only one basic search field. We have an additional table, pretty much configured like the original table this time, with columns and text inside for the name property. So having done this, what we need to do is also add these value helps to our XML view. So here, first, we define them as a dependent of the filter bar. So that the instances get cleaned up as soon as the filter bar is being destroyed. And we have to add the value help association to the name filter field. And here we just refer to the dependent which we just defined. So as you remember, our value help name gets the ID name value help, which we just refer here in this filter field. Okay, I think this is enough. So we can actually check if our value help already does something. And as you can see, we get now a nice suggestion. And on top of that, we also get a selection dialog where we can search this list for all the values which are available. Yeah, very nice. Let's choose one. We get this list where we can choose all the values that are available inside of our data. Okay, this worked pretty well. So, but if we want to also add the range value help now, we have a little problem. It won't appear here. As you can see, we just have the standard value help. So how is that? The delegate currently, the filter bar delegate currently doesn't really know about the value help. So we're just adding new filter fields via add item. So naturally, what we would need to do is implement a creation for the value help dynamically in the JSON filter bar delegate. How does the filter bar delegate know which fields are going to have value help? Therefore, we would like to use the concept of payload and add this information specifically for this filter bar instance in the XML view. So as we know, okay, we have for this particular filter bar two value help, one for the range property, one for the name property. We pass this to the delegate in the payload. And then we can add equivalently to how we did it before in the XML view. We can add the value help creation at runtime. So here, this is the new part. We decide by payload if for the current property we're building a filter field for, there is a value help available. And then we're going to fetch that. So we have another function which is called add value help that's just going to check if there is already a value help in the dependence, then we might reuse this. Otherwise, we construct a new value help as in the way that we load the according fragment and programmatically add it as a dependent to the filter bar and also set the value help association to the corresponding filter field. So that way we can make sure that also dynamically created filter fields will have the according value help. So let's choose the range here and see how this looks like. This time, this is a suggestion only value help. So we only have an indication for this dropdown, not for the dialog. And if I open it, you can see we get all of the values which are available as ranges here. We can choose one. We can say we check this first one and filter for it. As you can see, we only get the values which have the range Mahalangur Himalaya. Great. So far, that was it for exercise 4. You've learned how to construct value helps as fragments and improve the user's filter experience. I think you're ready to continue with exercise 4.
Okay, so in this exercise, we will learn how to use the type map feature of our delegates to create a little bit nicer visualization for some of our table's properties. In this case, the height, which, as you might have already noticed, is missing a unit. So we will try to change that by first creating a new type for this. Oh, maybe we should create a folder instead. Here called type. We will add a new file called length meter.js. We will add some boilerplate. This type will be an extension of an integer type. And we will override the format value method with a much nicer unit value. So there's our new type. To actually make use of this type, we have several ways to achieve this. We could, for example, create some new base delegate, which we leverage here as well. That's, I think, what the tutorial itself shows, but in our case, it should be sufficient to first create the type map, which again an extension of a default type map, which basically contains all the model independent types UI5 currently offers. And we will enhance this a little bit again by importing this default type map, but also adding our new type on top of it. This categorization, you can see here, base type numeric tells our controls what kind of type is to expect. This is, for example, useful if you want to format data for a field, and the field should know which value helps to display for edit modes, and some other scenarios as well. So we now have our type map and we have our length meter type. We can then head over to our known delegates and we can just use this type map and again add a new method to this delegate. Which just returns this new type map. The same we can do for our filter bar delegate. And we also need the dependency there. Maybe we should give it the correct name as well. And then the only thing left to do is to actually make use of the type on all the properties and all the locations where it's relevant. So the first thing we try to change is the height property in our JSON property info file. It will make use of the new data type. Same for the prominence. And we can also enhance the XML a little bit and change the according height column there as well, if we can find it. Correct it a little bit. And now when we reload the application, don't see anything because we did something wrong. Height is not defined, length meter. So we have a small error probably. Height is not available. So I think this should be in here. And voila, there is our new unit, which should also be available when we add the prominence, because we added it to the property info file as well. So this small exercise is now complete. So you know how to customize your types to enhance your visualization. These types are also relevant for personalization and for persisting values as well. So in this last exercise, we will learn how to actually persist the personalization we have enabled before in our controls by adding a variant management. And to do this, you basically only have to place the variant management control in the view and configure it accordingly for our controls here. You can see this variant management also has the for property configured to be attributed to the filter bar and probably the table as well. And now this is all we have to do. When we actually make use of the personalization, you can already see the variant management to the top left here. And if we, for example, add the height and say we want to see everything below 8,000 meters, and we want to save this as a separate variant, we can do so. We can do this. We can also set it as default, and you can now see you're able to switch between those variants. And if you reload the application, you still see this as default. So that's all you have to do, which is a pretty nice thing to have, I would say. Thank you very much.
I hope you enjoyed this little journey through application development with MDC in a metadata-driven manner. And if you have, leave us some feedback. You can open an issue on the tutorial if you found something. And yeah, besides that, I hope you have some more nice sessions at SAP's Devtoberfest, and see you soon.